Hey everybody, today we're on Unit 8, Lesson 4, and we're going to be discussing inverse trigonometry. In the past year, we've discussed numerous things, and one of these things has been the concept of an inverse function. How do we find an inverse function? Hopefully, switch x and y comes to your mind, okay? So whenever we want to find an inverse, we're switching x and y, and we solve for y. Our notation for an inverse function, if you recall from the beginning of the year, is that little -1. Now, it doesn't mean flip. In this case, that little -1 is saying the function we're talking about is an inverse, okay? And we also going to just remind you here how a function will have an inverse if it were to pass the horizontal line test, okay? And if it doesn't, we could restrict the domain to make it one-to-one. For instance, actually, I'll apply it when we get down here, okay? So let's just kind of see how this applies to the inverse of a trig function. Okay. So I'm going to focus right now just finding the inverse for each function. If y equals sine x, if I switch x and y, x equals sine y. And I want to solve for y. So what I'm going to do is use my inverse notation here. Sine inverse, sine inverse. Whatever I do to one side, I have to do to the other. This is going to undo. An inverse undoes itself. And you're left with y equals sine inverse x. The notation may seem weird, but it will get easier in a minute. Let's do y equals cosine x. X equals cosine y. Switch x and y, solve for y. So y equals cos inverse x. Y equals tan x, solve for y. Switch x and y, and solve for y. Now, in each of these cases, I want to just go back up. In this form, okay, right? Let's say we did this, it would be sine of 30 equals what, right? In this form, switch x and y. So when we read these problems, when we read through these problems, the example really reads, y is the angle whose blank, whatever trig function you're dealing with, is x. And x is going to be whatever ratio is in the problem. Okay. So instead, so now we're working backwards. That's what you have to think about. Now let's talk about some of the problems associated with this. In order for a function to have an inverse that is also a function, it has to pass the vertical line test. So in each of these cases, I need to get this out of my way. In each of these cases, we're going to need to restrict the domain. So for instance, when I think about the original sine curve, I know my curve goes like that and repeats itself in either direction. It does not pass the horizontal line test. So what mathematicians did, and this just has to be memorized. They said, well, if we only look at this section, we're going to get all the answers we need from -pi/2 to pi/2. In other words, in quadrant 4 and quadrant 1, -pi/2 positive, and we get the full range of answers. So our domain of a sine curve of the inverse is negative pi over 2 to pi over 2. What does this mean to us? Well, what does this mean to us when we're trying to find an answer? To one of these problems? Here's what it means. Think about how you set up a function value. If I ask you to find the sine of 30, what do? You think about the side lengths on the right triangle. So if I want to know what trig function gives you a sine of a particular value, you're going to work backwards off of that triangle. And then you're going to adjust your answer to the proper quadrant based on the function value. If it's negative, our answer is the fourth quadrant value of that angle. And if it's positive, our answer is the first quadrant value of the answer. So every answer is going to be based on the ratio itself. Use your triangle, and then adjust your sine. The ratio we get from the angle that forms that ratio. The sine is what quadrant to use. For the sine function, if the function value is positive, theta is going to be in quadrant 1. And if the function value is negative, we're going to use the fourth quadrant value of that angle. Maybe I should jump to it now, but let's just do all our rules first. Our cosine function, if you recall, our cosine function starts at 1, ends at 1, and repeats in either direction. This one, mathematicians, and again, this had nothing to do with me, decided long before I ever existed, the domain of the cosine, the inverse cos, is going to be from 0 to pi, with the idea that, right, you're going to see a full set of answers, the whole range of y values from 0 to pi, positive, negative, quadrant 1, quadrant 2. So the domain of the inverse cosine is going to be 0 less than or equal to x less than or equal to pi. Again, that's not so important. How to set up the answer. Ratio, always use the triangle and identify the angle you're dealing with. Adjust your sine. If the function value is positive, we're going to adjust the angle and use first quadrant. If the function value is negative, we're going to use the second quadrant value of that sine, and it's as easy as that. And with our tangent function, recall our graph. There's our one cycle. It doesn't matter because right there in our interval negative pi over 2 to pi over 2, or quadrant 4 and quadrant 1, we see all the negative function values and all the positive function values. So this would be our restricted domain. But to us, the important thing, how do we work backwards? Use the ratio from the triangle to get your angle. Adjust the sine based on the quadrant. Positive, our answer will be the first quadrant value of that angle. Negative, our answer will be the fourth quadrant, value of that angle. So a lot of stuff going on in the middle. What's important is how to find your answer. So let's actually jump to our problems, and you're going to see that this really does it's not as difficult as it looks. Just remember, every answer is going to be based on the ratio and the sign. The ratio, we're going to use our triangles and the unit circle if we need to. Some of you may prefer to get your values off the graphs now if you have them memorized. Doesn't matter how you get them. And then use the sign to determine the value of that angle. Up here, I have all of the information for you. Find the exact value of each inverse trig. So remember, when I read the problem, my answer is the angle whose sine is radical 3/2. I look to my triangles and I see radical 3's and 2's on this triangle. The angle whose sine is radical 3/2. From this angle, opposite over hypotenuse, or do I get it from this angle, opposite over hypotenuse? I'm going to get it from this angle. So I'm dealing with a 60-degree angle. All I have to do now is look, is my function value positive or negative? When I look at this, my function value is positive. So this angle is my answer. That's all. That's all you do. If I look at example 2, I should square this off. There's your answer. The angle whose sine is negative radical 3/2. Again, it's going to be a 60-degree angle. That's where I get my ratio radical 3/2. But now I need to adjust for this sine. So I'm going to have a 60-degree angle. But since my function value is negative, I'm using the fourth quadrant. I should go back and say that here. And what is the fourth quadrant value? Well, you can just represent it like that, or you can adjust it and represent it as a positive angle, but I'm perfectly okay, right? Instead of 60 degrees this way, we're going 60 degrees that way. That's all that means. And that's it. Function value, sine. The angle whose cosine is -1. I'm sorry, the angle whose cosine is 1. In this case, 1 is not one of my side lengths, right? I don't have that ratio 1/1. You have to start to be able to identify when it's going to be from a quadrant angle. So the angle whose cosine is 1 is going to be a value from a quadrant angle. And I just go and look on my unit circle from 0 to pi. That's all I'm dealing with when I'm dealing with the cosine. Which angle? Is it 0 or is it pi? Which gives me a cosine of 1? It's going to be 0. And that was using the unit circle. The angle whose secant is 2. Now, I've kind of tried to get you guys in the habit of like thinking, well, secant, that's messy. I'm not going to deal with it. Instead, I'm going to find the angle whose cosine is 1/2. Flip that ratio, and it's a lot easier to work with. The angle whose cosine is 1/2. Okay. Cosine is 1/2. Cosine is adjacent over hypotenuse, and that's going to happen at a 60-degree angle. I didn't mean them all to come out at 60. I'm sorry. But again, working backwards off our triangle, the angle is going to be 60 degrees. The function value is positive, so I'm using the first quadrant value of that angle, which is 60 degrees. Now, I do know that all of you know you can cheat and use your calculator, and I'd never be able to tell, but it would help if you guys can do this by hand. Arctan, that's kind of weird. Arctan, the word arc is just another way to say inverse. So if you ever see that, it's just like seeing this. The angle whose tangent is -1. Now this looks like this could be a quadrant angle, but it's not. Remember, the quadrant, the tan is 0 or undefined. This really comes from one of our triangles. So I look, the angle whose tangent is opposite over adjacent, and it's going to be from your 45, 45, 90. Arctan -1. My angle measure that gives me that tangent is 45 degrees. My function value is negative. So I'm going to take the fourth quadrant value of that angle, -45. Again, if you prefer to write it as a positive, you could say 315, but you don't have to. Why do more work than is necessary? Now I've got a multi-step problem here. First, I want to work on the inside out. I want to find this angle, and then I want to set up the sign for it. So now we're reading math a little bit more thoroughly. So I'm going to start inside here, right? The angle whose cosine is -1/2. Just going to draw my triangle. Hopefully, you guys now are seeing that it's coming to you a little bit easier. What angle gives me a cosine of 1/2? 60-degree angle. Except now my function value is negative. So I need to adjust this quadrant, this angle to be a quadrant 2 value. How do I adjust it for quadrant 2? You need to remember the value of an angle in quadrant 2 is 180 minus theta. So 180 minus 60 is 120. But I'm not done, because this is just the answer to that inside piece. I need to set up the function value of 120. The sine of 120 now is going to be the value. So I have 120. I'm going to be dealing with a 60-degree angle, right? So I want the sine of 60 in quadrant 2. The sine of 60, radical 3/2. And in quadrant 2, my sine is positive, and there's my answer. This one, if you go to try to do this on the calculator, you'd get a decimal answer, and I wouldn't accept it. So you really have to know how to work through these problems. The angle whose cosine is the sine of 7π/6. Right off the bat, hate 7π/6, so we're going to change our angle, right, to degrees. Angle whose cosine is the sine of 180/6 is 30. 7 times 30 is 210. Start on the inside. The sine of 210. So 210 minus 180 is going to be 30. So I want to find the sine of 30 in quadrant 3. Well, the sine of 30 is 1/2, and in quadrant 3, it's negative. The angle whose cosine is -1/2. Well, the angle that gives me a cosine of 1/2 is 60. But because this is negative, I'm going to adjust this to be my quadrant 2 value. And we know 180 minus 60 is 120. So that would be your final answer. And again, these multi-step problems, we need to do a little work. Now let's talk about a different situation. Sometimes we're going to be asked to evaluate or find inverse trig values that are not ratios of special angles. For instance, the tangent of the angle whose cosine is negative 1/3. When I think about my triangles, when I deal with my triangles, tangent, opposite over adjacent, I don't get 1/3. Opposite over adjacent, that is not 1/3, that's 1 over radical 3. Opposite over adjacent, that is not 1/3. Nothing on the unit circle gives me a 1/3. Okay. In this instance, when we don't have a special triangle to work with, we have to build a triangle for ourselves. So we're going to build what we need to use. I know that the cosine is adjacent over hypotenuse. That's my function value, right? Adjacent over hypotenuse. And I know when the cosine is negative, that means, according to inverse trig, I'm going to be building my quadrant in the second, my triangle in the second quadrant. There's my angle in the quadrant 2. Adjacent, -1. Hypotenuse, 3. In order to set up the tangent function, I don't need the value of the angle, I just need the side length. So I use the Pythagorean theorem, a squared plus b squared equals c squared. So y squared is going to equal 9 minus 1, which is 8. And y is going to be plus or minus rad 8, plus or minus 2 rad 2. Now think about it in terms of the triangle. Are we in the positive part of the x-axis or the y-axis or the negative part? We're in the positive part. So I'm going to label it with 2 rad 2. Then I'm going to use tangent is going to be opposite over adjacent. Notice my sign is right with my leg there. So the tangent of this angle, right, because that's all we did, is going to be 2 rad 2 over -1, opposite over adjacent, which we can just simplify to -2 rad 2. So we talked a little bit about how to work backwards with inverse trig and set up exact function values when we can recognize right off our special triangles and when we recognize when we have to set up a triangle. Okay. Thanks again and see you soon.